When dealing with frictional forces, we always need to be aware of whether or not the object is actually moving or if it hasn't begun to move yet. What we have is a crate of fish that weighs 18 kilograms. It's on the floor of a park delivery truck. We know the coefficients of friction between the crate and the floor are for static friction 0.450 and for kinetic friction 0.410. I want to know what are the forces of the friction as well as the acceleration if a horizontal force of 75 newtons east is applied to the crate. Before we can determine what the acceleration is, we must determine the force of friction. We begin with the static friction to determine if the applied force is enough to actually create motion. So the force of static friction, I'm going to work a little bit backwards here, equals the coefficient of friction multiplied by the normal force. The normal force of any object is the force exerted by whatever it's sitting on. So in this case, the floor of the truck. That normal force is equal and opposite to the force of gravity. And the force of gravity is mg. In general, any force is F equals ma, but since this is a gravity-affected force, we use g in place of a. So the normal force of this crate would be the mass of 18 kg times 9.8. Multiplying that out to 2 sig figs would give us a normal force of 180 newtons. We can now use that. We can calculate the force of static friction. The coefficient of static friction, 0.450. Normal force, 180 newtons. Multiplying that out gives us a force of friction of 81 newtons. Looking at this now, we've only applied a force of 75 newtons, which means we have not applied enough force to actually begin the motion of this crate. So since the applied force is less than the force of friction, there is no motion. We haven't pushed hard enough to move the crate. And since there is no motion, the acceleration is 0. Moving on to question B, now we're pushing a little bit harder. Now we're pushing with 95 newtons of force. We know that the force of friction will be 81 newtons. We found that in the last part of the question. So we will have motion. So since the applied force is greater than the friction force, this crate will actually move. Now because of this, we need to actually go back and now we need to determine the amount of friction of motion, the kinetic friction. Why do we need to do this? Because we needed to determine the static friction to determine whether or not we'd pushed hard enough to move the object in the first place. Now that the object is moving, there is less friction between the object and the floor than there was just to get it moving. So we've overcome the static friction. We need to now determine how much kinetic friction there is. We know mu k, it is 0.410. We found the normal force in part A, that's 180 newtons. Working that out to 2 sig figs means there's kinetic friction of 74 newtons. Once we know this, we can figure out the acceleration of the object. Remembering that acceleration from Newton's second law, F net equals ma. So before we start this equation, we need to actually determine the net force. How much of that 95 newtons actually goes towards moving the crate? So I'll do that right in here. That would be the 95 newtons applied force. Subtract the 74 newtons of friction. Means we get 21 newtons that goes into moving the object. Substituting that into F equals ma, 21 newtons here, 18 kg here, dividing that out, going to 2 sig figs, we get an acceleration of 1.2 meters per second squared. And since the force is being applied to the east, this acceleration will be to the east.